Hello friends, we are going to see one of the interesting problem in physics uh, that usually asked in a GATE or CSIR exam. This question was asked in GATE basically physics 2024. So and this question comes under solid state physics or condensed matter physics. So actually to be specific, related to Fermi surfaces and the density of states. The actual question is the crystal structure of two metals A and B or two-dimensional square lattice with same lattice constant A. Electron in a metals behave as a free electron, and Fermi surface corresponds to A and B are shown by solid circles in figure. So this is the first one is the metal A Fermi surface distribution or Fermi surface, and this is the metal surface metal B Fermi surfaces, along with the Berlin zone boundary, first Berlin zone boundary they added up. So this is the condition they have given. So what we have to find out is basically the value of NB divided by Na, right? So that means this is the electron concentration. The electron concentration in metal A and B is Na and Nb respectively. Okay, so that is the condition. So in this condition, we have to find out basically the ratio of, right, the electron concentration ratio between metal B and metal A. We have to find out, and then we have to match with the given option A, B or C or D. Which one is the right? So before going to solve this, let us read this once again. The question what they have asked is, they have given two metals, right? Metal A, right? So metal A. So this is in two dimension, right? Metal A is in two dimension. That is B also in two dimension lattice they have given. So the lattice constant, right? Lattice constant, right? Lattice constant is A. Lattice constant. Lattice constant is equal to A. That is lattice constant for metal A and metal B both are same, right? So that is what given here. Then further, right? So then what else they have given? Free electrons in metal behave as a free electrons in metal behave as a free electron. So therefore we have to we can take help of Fermi surface, right? We can take help of Fermi surface. So the Fermi surface corresponds to A and B are shown. That means metal A, this is the metal A Fermi surface. That means so this is the metal A Fermi surface, the circle which they have given. This is the metal A Fermi surface, and this is the metal B Fermi surface. So these are the conditions, and they have also given the electron concentration of A and B. This is for A and this is for B. That means metal A electron concentration is Na, metal B electron concentration is Nb. So then we have to find out the ratio between these two, right? That's what we have to do it. Okay, so then before then we will try to understand this problem first, or we will try to estimate the extract some values from the statement, right? So again metal B, right? So metal B, metal B is also in 2 dimension, and lattice constant is A. A is the lattice constant, right? A is the lattice constant. Okay, let us write it in this way, right? So let us lattice constant metal A, metal A. For metal A, lattice constant metal A, okay, and okay, that we know already, right? So lattice constant is A for metals, and what we will do is, now before going to discuss this lattice constant, so let us take this, try to understand the radius of this Fermi surface of A, metal A, right? Metal A Fermi surface radius. It basically, this basically starts at this point. This is a center point, and you move towards the Fermi surface. At this point, your the edges stops, or the Fermi surface ends, or it, right? So therefore this is the surface, and basically we want to calculate the Fermi surface radius, that is for metal A, which is equal to pi by A, because the Fermi surface and the Brillouin zone boundaries are in the same point, right? In the kx axis, it is ending at the pi by A values. Therefore, my radius of the Fermi surface for metal A is pi by A. So for metal B, right, metal B, kf B is equal to, we will try to find out the metal B kf, right? So radius. So basically for metal B, this is the origin surface, the sphere origin, and goes in this way, and it ends here. However, the Brillouin zone boundaries ends at this point. So therefore, so this is the point where we have values of pi by A, right? That is a pi by A value, and then apart from that we have some more length, right? So that means, let us say, that is some x. So now we can write the radius, right? The Fermi surface radius for metal B, we can write it as pi by A plus some x. So if you look at this diagram, right, this Fermi surface diagram for metal B, so actually, if you look at this, so this is a sort of, from this point to this point, it is kind of off of this distance. So that means, I can just write it as xs, right? Xs 1 by 2 of, 1 by 2 of pi by A, right? 1 by 2 of pi by A, or pi by A by 2, right? Pi by A by 2, half of pi by A, right? So this is just for, the approximate distance we will consider in order to solve this problem. Okay, so if you look at in this image, you can understand that it is this length. So up to this point, right, this point, the value is this, that is pi by A. Up to this distance, this is pi by A, and this distance, right, from this point to this point, the green distance is kind of off of this. So therefore I write it something like this, right? So then what we will do, we will try to simplify this, right? The kf value, we will try to simplify this. So that means pi by a times 1 plus 1 by 2, right? 1 plus 1 by 2, so that is equal to pi by a into, like, this is, if you simplify this is 3 by 2, right? So therefore kf b is equal to this value. Kf b is equal to this value, and kf a is equal to this value, right? Kf a is equal to this value. Now what we have to do is, we have to look for the relation, basically. So we know now na, and then we have to write some relation which is based on carrier electron density in the, so the density electron density, right? the electron density the electron density, right? So electron density n, electron density in 3-dimension case, the n is equal to kf square by 2, basically 3, right? So 3 pi square. This is for 3-dimension case. So for this is basically from density of, right? So density of state calculation, right? For 2-dimension, right? 2-dimension, the Fermi surface, for 2-dimension Fermi surface, the electron concentration and wave vectors are connected by n is equal to kf square by 2 pi, okay, 2 pi, right? So then what we will do is, for metal A, right? For metal A, we will write this relation, right? So for metal A, for metal A, right? The metal A, the kf, right? So kf A is equal to pi by A. So therefore, right? So therefore n is equal to, right? N is equal to pi square, or you can just keep it as it is. That means pi by A the whole square by 2 pi. For metal B, kf is equal to, right? So kf is equal to 3 by 2 this power square, right? Sorry, that is basically 3 pi by 2a, right? So basically 3 pi by 2a. So that means if you substitute the values, right? If you substitute the values for n is equal to 3 pi by a, right? So 2a square divided by, right, so divided by 2 pi, right, this is for A, so this is for B. So basically now we wanted NB divided by NA, therefore, right, so therefore you can just write it as 3 or 9, so NB, right, so NB is equal to 9 pi square by 2, right, so not 2 4a 4a square into 1 by 2 pi, so that is for NB, and NA is equal to, so we know that is this can be also written as, you know, so this is actually in the denominator, so that means the denominator factor should come something like a square by 5, a square by pi square into, right, 1 by into 2 pi, right, into 2 pi. So now we can cancel the common term. This is actually a, right, so we can cancel the common terms, so this and this one, and then 2 pi 2 pi, so remaining term is NB divided by NA is equal to 9 by 4, which is equal to 2.25, 2.25. Therefore NB is equal to NA, that is equal to you can approximate this is equal to 2, right? So that means you know, so therefore NB by NA is approximately or equal to 2, right, so approximately equal to 2. So this is what the 2. So therefore what happens here, you now go to the answer, right, so the ratio NB by NA is equal to 2, right, is equal to 2. I'll just quickly go to this step and put some other alternate ways to understand easily. So what we can do is, this is like NB, right, so NB is equal to this, that is NB by NA, and that can be written as 3 3 3 3 3 pi, right, 3 pi by 2a the whole square by actually let us write it as this, NB by NA is equal to 3 pi by 2a by 2 pi, then pi by a the whole square by 2 pi. So NA is equal to pi by a the whole square by 2 pi. So then we can just directly cancel here and we can write this, right, so write this, so that means this is becomes NB by NA is equal to 9 pi square by 4a square divided by pi square by a square, right, pi square by a square. Numerator denominator get cancelled, so n, right, n b by n a is equal to 9 by 4, which is equal to 2.25. Therefore NB by NA is equal to approximately or equal to 2. right? So approximately 2. Therefore, so what we can do is we can just go to the answer now and then check it what is the right answer, right? So what is the answer we got? So that is right, NB by NA is equal to 2 approximately, right? Or NB by NA is approximately 2. So or it is like 2.25, right? It is 2.25. This is equal to 2.25. So then if you look at the right option in this among four, the second one is the right answer, right? The second one is the right answer. So that means the NB by NA ratio is equal to 2. This is the close to our result. Therefore, option B is the right answer. So this is how we have to solve this. So for this case, we should know basically they have asked for in this question they have asked for the 2-dimension case, right? So 2-dimension, that is given here, 2-dimension square lattice, right? So 2-dimension square lattice. Suppose if they are asking 3 dimensions square lattice, 3-dimension lattice, right? So we have to use this relation. So for 1 dimension, there is a similar relation, that is for the n, right? For n, anyway, again we have for n, for 1D there is a different relation. So based on what dimension they ask, we have to choose the n values and then we have to solve the problem, right? So that's all.